Welcome to our review on conduction and convection. So when we're thinking about the ways in which we can transfer energy, then the first thing we're going to consider is how we transfer energy in a solid. So anytime we're looking at energy transfer in a solid, we're going to be talking about conduction. So if you think back to what we've done on particles going all the way back to year 7, then we know that particles, even in a solid, are vibrating. So what we find is, as we heat up that particular material, the particles then gain energy. And if they gain energy, they vibrate more. As a result of this, those particles that are vibrating more will collide with the ones next to them, and therefore transfer that kinetic energy from one particle to the next as they collide with each other. As you can see in the diagram at the bottom there, we start heating the left-hand end, those particles gain kinetic energy, they knock into the ones next to them, and so on, all the way along that solid material. If we consider reducing conduction then, first thing we need to understand is what makes a good thermal conductor. And the property we're really looking at there is the fact that they've got these particles that are arranged in a lovely regular pattern, very close together. That means it's very easy for the vibrations to be passed from one particle to the next. If we consider a thermal insulator, these are the ones that don't conduct heat well. So what we find is that their particles are close together, but they're not in this regular arrangement. Therefore, it makes it harder to pass those vibrations from one particle to the next. So what we find is that while our solids tend to be quite good thermal conductors, our insulators, or the poor thermal conductors, tend to be liquids and gases. So that's because we don't have this regular arrangement in our liquids, and in gases, as hopefully you remember from the particle model, then the gas particles are far apart from each other. This means it's much harder for those particles to come into contact and therefore pass those vibrations from one to the next. So we can actually apply that knowledge in our homes if we want to reduce conduction by using those principles. So if you think about double glazing, which lots of us have in our houses these days, then what we've got there are two panes of glass, and between them we've got this layer of gas. So what we're going to see there is, obviously the heat is going to be able to travel by conduction through the pane of glass, but then it hits that layer of air. So at that point, because the air is not very good at conducting the heat, then what we're going to find is it reduces the energy loss through conduction. The second method of energy transfer is convection. So if we're thinking about what tends to use convection to transfer that thermal energy, then it tends to be fluids, so liquids and gases. So what we will find here is that when we're looking to see the method by which energy is transferred through a fluid, then we're going to be looking at convection. So in the picture at the bottom, I've given you an example of how this works in our houses. So we've got our radiator on the bottom left of the picture there. So what happens is, obviously the radiator is going to be transferring thermal energy from inside to the surrounding air. Now as that happens, then the air becomes less dense, and therefore it rises because it's less dense than the surrounding air. So the warm air rises up, and then as it travels along, it's going to transfer its energy to other particles and therefore cool down. So that means that as it gets cooler, it becomes more dense, and therefore it starts to sink down towards the bottom of the room. So what we actually see is this ability to set up something called a convection current. So the warm air rises, it loses the energy to surrounding particles, becomes more dense and sinks, and it will continue in that little pattern over and over again. When we're thinking about how to reduce the amount of convection that we experience within our homes, then what we're looking at doing is installing insulation. Now the two types of insulation that will reduce our convection would be cavity wall insulation. So between those two walls we put in this insulating material that prevents the convection currents and therefore reduces the loss of heat, and also using loft insulation, which will prevent those convection currents within our house and again prevent the heat loss from the roof.